This is Remmete RTKS-L Cool Leopard. Remmete sent it to me for my review, which is significant and speaks volumes about the company. So as you can see, this is a pretty hefty knife. Is it overbuilt? I don't think it's overbuilt. I think it's built correctly for the niche. Survival pocket banger. The overall geometry of the blade and the lockout sliding lock here. They tell me they expect this knife to be heavily used and abused. So let's see how it compares to other large pocket knives in my collection. Here's Cold Steel AD10 Demco and Sniper Blade Works DMF. Both of these knives are made in Taiwan. Also from Taiwan is Demco 20.5 on the bottom. And then there's the US made Demco 20. Let's continue with the US made theme. From Spyderco we got Manix 2 XL on the top and PM2 on the bottom. Now let's talk about the lock strength. Will this knife outperform or perform at least equally to AD10, equipped with the incredibly strong triad lock? I would say yes and no. If you're thinking about tough campsite tasks, it probably would perform just as well as a triad. And I'm talking about batoning, splitting wood, prepping for fire, cutting food, and so on. You know what? If the video doesn't get too long, I'll go outside and test it. Without a doubt, it's a heavy-duty knife and built accordingly at 224 grams, 7.9 ounces. Overall length of this knife, 8.5 inches or 215 millimeters. And the blade length measured from the handle is 3 7/16 or 93 millimeters. The cutting edge, considering both parts of the edge, is 3 3/4 inches long, and in millimeters it is 95 millimeters. Right, just maybe a hair behind the pivot. It's balancing right there. Considering that there's a flat titanium slabs without any internal sculpting, that's pretty amazing. The action is, by the way, very smooth. It has a little bit of friction in the bearing area, and when I open it up, we'll see what's causing it. But let's continue with the measurements. I'm going to measure behind the edge thickness here, and then the blade thickness. 22 thousandths of an inch, which, considering that the blade is, 216 thousandths of an inch thick, that's quite a fine edge. Pretty impressive. So the slicing capability of this knife, it's not going to be quite Manix 2 or hollow ground blade on some other knife, but it will slice better than the AD10 because this guy has 34 thousandths of an inch behind the edge thickness, while the blade is only 152 thousandths or 153 thousandths of an inch. So maybe there's some noticeable difference, but we need to test this theory. If you don't think trying to cut unsupported, untensioned paper towel is easy, I recommend you try it with your sharpest knife and let us know what happens. What I expect from the sharp blade is biting into the edge of the paper towel from any direction and then continuing the cut without tearing it. Recently I had a funny comment. Somebody said, "You're going to resharpen a knife anyway, so why do you feel it's important to show how sharp it is out of the box?" My response was, that shows how much respect a knife's manufacturer or maker has for the end user. Because to charge any amount of money for a knife that doesn't cut is unacceptable. Now this knife bites in and cuts well, but because the horizontal section of the blade is so short, it's only about 2.5 inches. And because there's a crisp transition between the horizontal edge and tanto section, it was a little hard to keep the blade engaged through the entire cut. I don't want to give you an impression that the knife is difficult to use. Let me grab a piece of cardboard and illustrate. Whoa. Really nice. Not a problem at all. And here's the venerable AD10.
Yeah, the thicker behind the edge dimension kind of makes a difference. Look at that. Typically, I look at the edge under the microscope before I do any cutting tests, but somehow things got out of order for me today, so I'm using my very inexpensive Amazon purchased USB-C microscope to look at the edge. This microscope became an essential tool in my sharpening arsenal. The affiliate links to the microscope and other sharpening and maintenance tools are in the description. It really helps my channel out if you use these links, but you don't have to. Let's focus on the tip here. The condition of the tip tells me how experienced the person was who sharpened this knife, and as you can see, this is a near perfect tip with almost no radius in the front, and the rest of the cutting edge is looking really good. I don't see any issues from cutting that much cardboard. A poorly stropped edge would show little tears where the burr, oh, just as I said it, there's the spot right there, just a little bit. The rest looks good. Yeah, so this tearing effect is from burr that was left on the apex catching a fibrous material and being torn off. Looking straight at the edge, I feel like they could have stropped it a little more. But in a mass production factory, it's kind of hard to establish that golden middle where it's stropped well but not overstropped. And, you know, it takes a trained person to do it perfectly right. And so I see a little bit of the rolled over burr in a couple of spots, so I'm going to see if I can strop it out. I use a double-sided leather strop made by Beavercraft in Ukraine. I recently saw a video by King of YouTube Sharpening where he critiqued this particular strop for leather being too smooth. That was kind of silly. He was concerned with how unevenly the diamond paste was distributing on the leather because the smooth side of this strop is very smooth. Anyway, what I do is I put leather conditioner on both sides right before I apply diamond paste, and what it does to the leather, it opens up the pores and lets the diamond paste be absorbed very easily. Yes, I know somebody will comment that using diamond paste means I'm no longer stropping, I'm honing, and I will not disagree with that. Yes, there's some element of honing involved whenever you involve an abrasive. My rule number one for stropping: there are no rules in stropping, other of course than don't cut into the leather, pull the edge off of the leather, if you know what I mean. Well, if you don't know what I mean, you'll find out when you try that. As you just saw, I didn't have to do it for very long, and here is the blade now under the microscope. Let's see if the edge been properly restored, and sure enough, look at that, the apex line disappears, becomes almost invisible. So, success. Try it at home. Again, the links are in the description. I have the diamond paste in there too. I did get a chance to get outside and try it out in a non-premium knife situation. I mean, if a premium knife has these lockout features and hefty blade, you know, it's a batoning knife. Every time I do this, I get a dumbass comment that I should be using the right tool for the job. So here's my response that covers all of these comments. If you are not a professional lumberjack, you have infinitely more chances to hurt yourself with an axe or hatchet than doing this with a knife. And by the way, this is a branch of the fallen oak tree. It's dry and not rotten at all. And I'm looking at the knife. The blade looks great. There's no loosening, no rocking. The safety lock did not unlock. This polished, textured, bluish-purple anodized handle and a satin blade make it look like it's a dressy knife. But let me tell you, it's a tool. It's a prying, chopping, batoning, do anything with monster. Now, the only criticism I have The slant on the handle doesn't allow me to hammer it in very deeply. Maybe I'm not using the right baton, didn't have time to locate the bigger one. So I would love to see a squared off handle version of this knife. And of course there are other overbuilt looking knives from China, but I watched a video that MC did where he broke Meguron, I think, and I tested a Remmete T1000 in a similar way, and let's just say it didn't go as smoothly as this. Watch the video if you own that knife. And here's batoning. Now this should be straightforward. It is possible to split a piece of wood with any knife, no matter how light duty it seems to you, but unlock the blade before you do it on a light duty knife, like a bug out style knife. And then all the stress will be on the blade and not on the pivot or lock. Another big like for me is the overall blade geometry. You see it lies somewhere between EDC Slicer and Scandic Ground Bushcrafter. And that means I can do really fine feathering after I'm done batoning with this knife. A lot of good design decisions went into this tool, and to determine if manufacturing kept up with the design, we're going to disassemble this knife, assess machining quality, and then test the blade for hardness. I left the pivot at the factory setting and removed the back screws first, and as you can see the frame sprung out a little, and that tells me the pivot is torqued too much. To adjust or remove a pivot screw, a T20 driver bit is required. These are not usually included with the multi-bit systems like the Hoto in my hand. And wow, it's Loctited to hell and back. I just can't move. I can't apply enough torque to unlock it. What do they say? Desperate times call for desperate measures. So here we go. A soldering torch. I usually hold it 5 seconds on each side of the pivot screw when I run into stubborn screws like that. It's a lot easier to do on the metallic handles, a lot harder to hit it right on the G10 on my Carter handles, which I have done. And now, there you go. Basically it melts the Loctite if you let it heat soak a little bit. Look at the amount. People at Remmete, if you believe in yourself, you don't need to believe in Loctite. If you do everything right at the factory, Loctite is not really necessary. And definitely not in these amounts. Another piece of evidence that Remmete employs very enthusiastic comrades. It is the second Remmete M390 blade that I'm reviewing that has this discoloration where they ground engagement surface for the lock bar. And anyone who knows metallurgy can tell that due to its brownish coloration, this edge reached 700 degrees Fahrenheit. Perhaps Remmete engineers are not worried because there's a replaceable lock face plate on the frame, which I'm going to remove and I'm going to test for hardness. So this interface plate has to hit a certain hardness window where it's harder than the titanium, for better wear resistance than titanium would have had, but softer than the blade itself, so that it wears faster than the blade face. Therefore, I'm expecting like 45 to 55 HRC if Remmete knows what they're doing, which they probably do, judging by how precisely that plate interface to the lock bar is machined. Takes some doing to remove it, but to remove it, I will. This component is pretty small, so I better mark a couple locations for the diamond penetrator poke during the test. Here we go. As always, I start my tests with calibration of my Rockwell hardness tester, and for that I'm using this independently certified, serialized, and rated at 62 HRC calibration block. I sped up this segment because the video is getting pretty long. I also edited out the boring parts where we sit and wait for the load to be fully applied. And don't skip to the end because the last two pokes will be on the log bar plate. Question: if you are not a subscriber to this channel, may I ask you why not? And if you know of any other channel who can go in such depths and lengths to deliver accurate content, please let me know and I will subscribe. The calibration is verified to be spot on, 62 HRC. And now we are jumping into testing the blade. The last Remmete I tested that was made out of M390 came in between 61.5 and 62 HRC.
And here on the very first poke, we get 62.3 HRC. And this is significant because to get M390 to above 62, we got 62.2 on the second poke. So to get it above that level, it requires pretty serious cryogenic treatment after the quench and both tempering cycles. 62.3 on the third poke, which gives us an average of 62.3. That is pretty impressive, and now we're moving on to test that log bar plate. Typically, these type of components are made of 410 or 416 cold rolled steel that comes from the mill at about 36 to 40 HRC. Anything above it will be evidence of additional heat treatment that these parts undergo at the factory. And we get 53.3 on the very first poke. That's good news. Let's do another poke just to double check. It's a little challenging to find a spot that is sufficiently removed from the first poke or edges of the part. We got 51.0 HRC, which is proof positive that this steel underwent additional heat treatment either at the mill or at the Remmete factory. I found that T9 Torx bit work best for disassembling the handle, and these screws are actually machined at Remmete factory. They don't look to be catalog screws. The pivot fits very snugly into the handle, and the bearings are of a multi-row solid brass frame tungsten ball type. Basically skiff quality. Let's see the blade's fitment to the pivot stem, and it's a non-interference loose fit. Not too loose, but not as tight as a slip fit on the frame. Why is it important? Because the type of fit controls how much rocking can a blade get if the pivot hardware starts coming loose. It is possible they machine it to a tighter fit, but during heat treatment it is not uncommon to have a little bit of a shrinkage in the most heat affected zones of the blade. Next, I'm reattaching the log bar plate back to the log bar. Like I said, it's a very tight fit here, so I have to actually work its way into the pocket. And it's important to gradually torque the two screws that hold it to the log bar. Otherwise, you're risking deforming the plate at the edges. These are pretty robust screws, which means you can torque them pretty good. Just go one at a time, interchangeably and gradually. I don't know why you would need to remove this plate, especially since the replacement plate is not provided. On the other hand, even if it was provided, the fitment actually takes some skill to ensure a proper interface between the replacement plate and the blade. The rest of the assembly is just like any frame lock. You just line it up and then it kind of snaps in place. Because I saw that handle halves sprung apart when I started assembling this knife, I'm going to start assembly with a central screw. The screws are the same length, except for the pocket clip screw is a little longer. So I'm starting with a middle screw. As you can see, the pivot screw is not in at all at this point. And then I am going to move on to the rear screw. And I am not torquing them, I'm leaving them quite loose. And now I'm going to drop the pocket clip into the pocket that's cut out for it on the frame. And this fit is also very, very snug. You can see without a screw, it's not falling out. Very, very precise machining again. Man, they really proved themselves to me as far as their machining capabilities. And this screw, I am going to torque all the way, which should cause the frame springing apart near the pivot. This is the approach I developed to achieve two goals simultaneously. Firstly, this ensures the proper parallel alignment between the frame halves, which in turn means smoother operation of the bearings. Secondly, it turns the frame itself into a locking feature, eliminating the need for Loctite. Notice how carefully I'm closing the blade. The pivot is not tightened at all, so I don't want the blade scratch the titanium on the frame. And now I'm tightening the pivot screw, and you should be able to see how the blade starts centering itself as the torque increases. right there you should be able to see it's a little off center, but as I'm continuing to torque the pivot, it finds its way toward the center. And now we are ready to torque the frame screws and test the knife for function. This particular knife makes beautiful sounds, and I'm regretting being overly critical of the reviewers who focus on acoustics of the knife. I'm kind of starting to see their point. So finally I go around and make sure that all the screws are fully torqued. All right, function check. In this case, I would actually call the action hydraulic, because you kind of feel and hear components interfacing, but it's still very, very smooth. No blade rocking, no bearing rattling, just a slight hydraulic hiss. And that is a sign that the frame halves are not completely parallel. So I'm measuring the gap at the back of the handle. It's spot on 250 thousandths of an inch, which is kind of strange on a metric knife. Did not expect it to be spot on like that. And so let's measure the front with the blade open first. And what do I get here? Sorry about the glare. We got 255 thousandths, so it opens up 5 thousandths of an inch toward the front. Let's close the blade and measure this gap again. And now we got a little bit of a reduction. We're at 253 thousandths of an inch. I've seen tighter tolerances, but on like a $1,000 knife. So I'm happy that they put the highest grade bearings in there, but they kind of wasted a little bit of money here because the parallelity should correspond to the quality of the bearing, like on a couple knives that I reviewed recently. I don't want to leave you with an impression that this little nitpick deters me from carrying the knife. I absolutely going to carry the knife. It sort of rings all my bells, and I really like the action. Even the front flip, which I don't normally do.